Deep within the core of our sun holds a region of dense, superheated plasma, where free particles of hydrogen are able to collide into heavier elements. 2 hydrogen into deuterium, and 2 deuterium into helium, as well as a small amount of energy. This process happens constantly. 600 million tons of hydrogen are fused every second, resulting in the equivalent of billions of nuclear weapons released in energy. Energy rises through convection and is emitted into space. This cycle of convection results in magnetic fields, which can potentially reach far into the sun's atmosphere. When one of these magnetic fields break, the reconnection can launch large amounts of plasma and radiation into space, also known as a coronal mass ejection, or CME. Close up, a CME looks immensely powerful, but what about on Earth? With modern technology, we would have about a 3-day window to prepare for an impact. CMEs are frequently emitted by the sun, and the few that hit Earth are minor. Although a rarity, there's always a chance that a massive ejection could occur. If a strong CME were to hit Earth today, the impact would be devastating. The most immediate effect would be a loss of power. In previous, smaller events, CMEs tripped circuit breakers and overloaded telecommunication lines. In a major occurrence, transformers could explode, severing a vital link in power grids worldwide. Additionally, GPS and other satellite-based functionality would be damaged or destroyed. Except for a large dose of radiation for astronauts, the risk for humans is quite minimal. Despite this, a direct impact on Earth would cause billions of dollars of damage, and rebuilding the worldwide power grid could take decades. Let's take a step back. Our sun is powerful, and yet it pales in comparison to some of the supergiants that exist in the far reaches of the universe. Once a star begins to die, the rate of fusion in the core begins to fall. This decrease in pressure causes the star to collapse in on itself. In a supergiant, the collapse creates a black hole, and the remaining supernova shoots a jet of energy into space, known as a gamma ray burst. If a CME hitting Earth was rare, this is near impossible. The likelihood of a narrow burst of energy hitting our tiny planet out of 1 trillion others is incredibly unlikely. But what if it did? A weaker or more distant gamma ray burst would have a small or unnoticeable effect. Other than limited damage to the ozone layer, there would likely be no impact from a minor event. However, a stronger gamma ray burst would strip ozone layers and cause chemical reactions in the atmosphere, resulting in greater ultraviolet radiation exposure for life on land and an imbalance of chemicals for life in the sea. In the worst case scenario, a gamma ray burst could hit us with a lethal dose of radiation, instantly eliminating all life on Earth with no warning. Realistically, the odds for that are incredibly low, but they aren't zero.